Welcome to find the largest almost missing integer, LeetCode 3471. We look at sliding windows of size k, find values that appear in exactly one window, and return the largest. If nothing qualifies, we return -1. Today, we dry run examples, learn the case split, then write the code. You are given an array nums and an integer k. An integer x is almost missing if x appears in exactly one subarray of size k. A subarray is a contiguous slice. Count how many curve windows contain x. We want that count to equal 1, then pick the largest such x. If no candidate exists, answer -1. Take nums 39217 with k equals 3. There are 3 sliding windows, 392, then 921, then 217. Each step slides one index forward. Our job is to count which values live in exactly one of these windows. Dry run the counts. 3 appears in one window, 9 in 2, 2 in 3, 1 in 2, 7 in 1. So the almost missing values are 3 and 7. The largest is 7. That matches the official example output. The key insight is case analysis. When k equals 1, we care about unique array values. When k equals n, the whole array is one window. When k is strictly between 1 and n, only the first and last elements can possibly appear in exactly one window. Middle values sit in multiple windows. Case k equals 1. Every single element is its own window. So almost missing means the value appears exactly once in the array. Use a counter. Return the maximum value with frequency 1. Example, 00 with k1 has no unique value, so answer -1. Case k equals n. There is only one window, the entire array. Every value in the array appears in that single window, so every distinct value is almost missing. The largest almost missing integer is simply the maximum of nums. Case 1 less than k less than n. Only nums at index 0 and nums at index n-1 can appear in exactly one window. If either end value also appears elsewhere in the array, it is disqualified. Return the max of the valid ends or -1 if both fail. Example 2. Nums 397217, k equals 4. The first value 3 appears in exactly one window. The last value 7 is duplicated in the array, so it is invalid. Middle values appear in multiple windows. Answer is 3. Algorithm steps. If k equals 1, return the max unique frequency 1 value. If k equals n, return max of nums. Otherwise, check index 0 and index n-1. An end is valid only if that value appears once in the whole array. Return the max of valid ends, else -1. Time order n, space order n. Here is the full Python solution. For k equals 1, use counter and take the max value with count 1. For k equals n, return max nums. Otherwise, define a helper OK of I that returns nums of I only if it appears once, else -1. Return the max of OK0 and OKn-1. Example 39217 with k3 returns 7. Why do middles fail when 1 is less than k less than n? The first element only starts the first window. The last element only ends the last window. Any interior element is covered by at least 2 overlapping windows. That is why the smart solution only checks the 2 ends. The helper check is simple. Function OK of I returns nums of I if nums count of that value equals 1, otherwise -1. Then answer is max of OK0 and OKn-1. If one end fails, max with -1 still keeps the other end. If both fail, you get -1. Key takeaways. Almost missing means appearing in exactly one window. Dry run window counts for intuition. Case k1, max unique element. Case k equals n, max of nums. Middle k, check only the 2 ends for uniqueness. Return -1 when no candidate exists. That is, find the largest almost missing integer.